We are now getting ready for the last part of the first cycle of data takings of ALICE. And so this is particularly exciting as a moment, because before going for the first long shutdown, ALICE will have covered the essence of the first overview of the whole physics program. We will have taken data with proton-proton, which is our reference and baseline. We will have taken data in 2010 with low statistics, and then high statistics in 2011 with the nuclei. And this program gets completed now with a run with collisions of protons and nuclei. Why collisions of protons and nuclei is pretty obvious, because whenever we measure effects in lead-lead collisions, what we measure in fact is the difference between what we obtain in lead-lead and what one would extrapolate for lead-lead from proton-proton. But when you are at the LHC, what you have is a nucleus that is not the same nucleus at which you are looking at lower energy. You look at a different X region, therefore you have different effects. It's looking at very high energy at the nucleus. It's really looking at a different object than what you are looking at lower energy. So in order to understand the origin of the effects that you are measuring at very high energy, you need not only a reference with proton-proton, but you also need a reference with proton-nucleus, where all the effects of the nuclear structure can be then subtracted from your final effect. And that is particularly clear and evident if you look at the result we have obtained during the short pilot run that we had in September, which was only a few hours, but could already allow to measure, for example, the rate of what is measured in proton-nucleus with what is measured in proton-proton, and therefore construct this curve as a function of transverse momentum, of the number of particles that you have a certain transverse momentum in proton-nucleus and in proton-proton rescaled. And there you find that you find a curve that goes essentially to 1, and therefore that there is no effect from cold nuclear matter, and therefore that the entire suppression of about a factor of 5, remember it's a very large factor that we observe in lead-lead, has to be attributed to the interactions of the partons in the plasma, and therefore it is at that point completely to be attributed to these effects. This type of measurements we will be doing for a number of observables. For example, we will be looking, one of the ones which will be most important will be measurement of quarkonium. We have observed an extremely interesting behavior of J-site production. Now, how much of that is to be attributed to the structure functions in the nucleus at the LHC, and how much to first the interaction and then to the combination in the system? Well, that requires a measurement in proton-nucleus. This is one of those we will be doing. Yet, what we have started to observe is that there are also very interesting observables specific to proton-nucleus, which seem to promise to open a real new window of physics in this energy regime. And our first paper on correlations with the observation for the first time of a ridge both in the near and in the away side is just somehow the beginning of a field of work in trying to understand what are the processes involved at the base of this type of observation in proton-lead collisions. And all that will require high statistics, so we are really looking forward to the full run, which starts in January, and that somehow closes our first cycle, that then we will repeat at higher energy, twice the energy, just after the stop. So we have a long shutdown one. After the long shutdown, we will be operating at twice the energy. again, for a cycle of lead-lead and proton-lead collisions and proton-proton collisions, and but that not with the current ALICE detector, but with a detector which will be more performant, because we will have installed the decal, which will give us ALICE back-to-back gamma jet and jet capability, and we will have completed the transition radiation detector, which already now is triggering, and will be then much more effectively triggering, having the full azimuth coverage. In the meantime, we will of course be preparing for the next long shutdown, where we will be installing the new ALICE for the one which has been approved recently for the upgrade. So it's a very, very interesting progression that we will see. And also, in some sense, also for analysis, it is quite timely now to have a break in the data taking, because there are more complex analyses that require longer lead time and require not to be under the continuous pressure of always new data, but to be allow the people to think carefully and develop longer analysis that will tackle more complex problems. We have done so far somehow the first generation of analysis of lead data at the LHC. There are more complex observables that we will be attacking, having the time of the long shutdown.